Okay, this is basically going through the full shebang of adding some bosses inside here and then fucking doing a mold cavity, which is, you know, I only was able to watch the video of this being done, so it'll be kind of neat to do it for real, I guess, and I'll probably end up doing it again later if you get a plastics machine. I think I've done that. I think I did this 3 years ago. I probably did. Anyway, let's see, mounting boss, right? Okay. Gotta insert it right there. Okay. There's actually a circular sketch drawn on there. I didn't see that. Right there. That's actually part of this sketch here. See it? So, that's interesting. Mounting boss. Okay, I'll select the face. Right there. Okay, and then select circular edge to position the mounting boss. I'll select that circle. And for select direction, choose this top face. We're going for pin bosses here. So we put a female pin boss. And the diameter of the base. God damn it. Anyway, I'll fill these properties in. Diameter of the base is 5. Graph angle of the main boss is 1. Anyway, I'll just tell you what I did. Yeah, diameter of the boss right here is 5. Okay. Click select mating face. Okay. Then select the top face of the boss, as you did in step 4. This is right here. Alright, that brings it up to that height. Okay, and the draft angle should be 1 degree. God damn it. The main boss should be 1 degrees. Okay, and then the height of the whole pin should be 20 millimeters. Where the fuck that is. Set inner number of fins to 0, so they don't want fins in this. Click OK. Okay, so I need to do that again to create one over here, apparently. So I'm going to select that face. For the direction, let me use the filter face option. Okay, and for the circular edge, where'd the damn sketch go? Right here, I can hardly see it. Okay. And I guess we want a hole here. Select that. Okay, and damn it. Okay. It's already about that height. Draft angle of the main boss, 1 degree. Height of the whole pin, 20, 0 down here. Diameter of the boss, 5. Okay. Alright, that should do it. Okay. Now I assume we're going to mirror these features. Damn it. Okay, I'm going to select this point. No. Oh, god damn it. Okay, select that point. Front. Okay. And it's going to be our mirror plane. I don't know why we couldn't just use the standard. Didn't they draft this thing right? Well, I couldn't use one of the standard planes. Okay, now features to mirror. We're going to want to mirror these two bosses we created. That should get her did. Alright, oh shit. Let's put this upside down. Okay, let's go do a draft analysis. Direction of pull should be the top plane. Okay, set the 0.5 as the anyway, our direction of pull is up. Okay, now we got some draft issues along here. This looks pretty good. On the bottom. What the hell is that? Hell. Well, that's not supposed to be there. They're probably putting that in there on purpose. Yeah, that definitely shouldn't go all the way through. Edit. Okay, we don't want that to go 20. Let's take it to like 15. Looks like that did it. Okay. Yeah, the only issue we have is that has 0 draft on it, so that's going to be an issue. All right. So selecting face classification, it tells you how many faces, but 8 faces that have draft issues on them. And you can hit the show hide button, which leaves us with those being the problem faces, which are clear enough to identify. Okay, now we're going to go do a draft and do a parting line draft, and this is in the Mold Tools version. Set angle to 1 degree, which it is. Under direction of pull, select the top plane. Okay, so we need the arrow pointing down, and that makes sense. This is the arrow we're going to be screwing with right there. Okay, so I'm going to select each edge along the bottom of the model. But I can use the select tangency command on it. And pull in all the edges. Okay, we're going to lower arrows scale's pointed up, which is good, I think. Yeah. Okay. Click to add draft. Alright, and that brings them into compliance. That's what we're looking for. Okay, now we got to scale the part using this scale tool to account for plastic shrinkage in the hot mold, and we want to scale about the centroid. Uniform scaling set at 1.05. Set OK. And that just blows the model up, you know, for the purposes of our mold, I think. Yeah, this tutor is actually pretty informative, so it's interesting, some of the stuff that's got in it. It's a good read for later on, you know, but it's good to have a video for you to watch too and see what I do. Yeah, and don't forget that, you know, Stratus is deal on, you know, the injection molding. It's at www.stratusysdirect.com/resources/injection-molding. So, and I saved a HTML site down in your little jobs folder, I think on the C drive, and I don't think it's the one in the documents with your C programming in it. So I got that version, and of course I do have links under job training, Solidworks, and various other places. So anyway, of course, you know, uniform wall thickness is one of the things they mentioned in the Stratus deal. Helps prevent warping. But if you can't have uniform wall thickness for some reason, the change in thickness should be as gradual as possible. Okay, when bosses are attached to walls, you know, which is best to avoid it if you can, but if you got to put a rib, you know, to the wall, it's best to make that very thin, about 50 to 60% of the nominal wall thickness, so it'll prevent, shrinkage. You know, it can create sunken areas basically where it attaches. You know, you should definitely never, you know, if you have like a square box, never locate the boss right in the corner with no ribs or nothing, because like I said, that'll create a massive shrinkage problem around the corner of the walls. So again, inset the bosses, you know, always. It's like we're doing here. Okay, nominally, you know, the wall thickness of a boss should only be about 60%, of your nominal wall thickness. But if the boss is going to be located in a non-visible area, like we're using self-tapping screws, you may want a thicker wall because of the stresses the screws create, so you can get away with it as long as the blemishes will be something you can live with. Now the depth of your screw hole actually should be about 30% of your thickness into the wall, so it kind of burrows in. If you got a wall here and there's the inner surface, well, this should go inside of it. And your height on the bosses should be less than or equal to 5 times the thickness, preferably the nominal thickness. So and it should have radius corners both in the bottom of the pin, so the pin that's in there, can be pulled out. The tip of it should be radiused, so it'll prevent pin burn, of your hole. And this is the blind hole, the one that the screw goes into, by the way. Not the part where the screw head is accessed. It's not the it's the female mate. But then it should have radius, dimensions that are greater than or equal to 25% of the thickness. So around the base of it, around here, should have a fillet around it, which we don't have, but should be about 25% or greater of the thickness of the wall. So, but again, this hole here, just like this hole we created here, it should be, it should extend down oh, geez. I guess section view doesn't work with this thing on. Damn. Oh, it does. It just, you can't see it. Turn off draft analysis. Okay. Now see, our hole right here, again, this wall thickness nominally, should be, like I said, about 60% or less of our wall thickness here. And this should have a radius around the base of at least 25% of the thickness or greater. So, and this hole should be, basically not just flat at the bottom of it, it should be spherical. So, and it should dip below this surface here, by about 30%, so that it minimizes this whole thickness area, so it'll reduce the likelihood of blemishes, sunken areas from forming. Now, when you do have ribs in your part, which, these are sort of ribs right here, it should only be about 60% of our wall thickness and no more for internal stiffening ribs. And and if they do connect to side walls, they should have fillets around the edges as generously as possible. Again, you don't want to get too carried away to where you create blemish spots, you know what I mean? So it's a compromise, but you're looking at least 25% of the thickness for the radius. Now, if you have two, ribs crisscrossing each other, it's sometimes good practice to core right in the middle of it. Although sometimes I wonder if they're just telling you that to, throw increased tooling cost at you. But if they have like a, rib going this way and a rib going this way with a little hole right in the middle of it, where the two ribs join up, just to kind of minimize the material. But, it seems like you can create a diamond pattern or something and achieve a similar result and lower the tooling cost, because that's still a lot for, to try to pull out a bunch of tiny pins from a mold. Okay, it says ribs, should be limited in height to 3 times its thickness. So, now that's 3 times the nominal thickness, though, not the rib thickness. So, and it's better to use more ribs that are smaller rather than one big stiff rib for obvious reasons. And the distance between the ribs should be greater than 2 times the thickness, greater than or equal to 2 times the thickness. So, with wall thickness of the ribs being equal to 40 to 60% of the overall thickness. So, anyway, okay, when it comes to draft angles, typically 1 to 2 degrees of draft angles, of draft, is the preference with an additional 1.5 degrees per 0.25 millimeters of additional depth or additional angle added per depth of texture. So if you're adding a textured surface, you know, for every 1/4 of a millimeter, which is about 10 mil of texture thickness, you know, got to add an extra 1.5 degrees of draft to it. So as a rule of thumb. All right. Yeah, that's right. You know, they have their, oh, it's 0.025 millimeter. Holy shit, yeah, that's way more stringent than I thought. I thought that seemed awful depth. You know, it's 1.5 degrees of additional draft per 0.025 millimeter. In other words, it's only about 1 mil, you know, of texture depth. So, so that's, you know, you got to add that to the baseline 1 to 2 degrees. So, you know, for every 1 mil of texture depth. Yeah, for normal office type equipment like computers and stuff like that, it's really only about a 1 mil deal. So apparently, you know, the minimum draft would be actually 1.5 degrees, you know, for a 1 mil thickness texture. So you wouldn't have to add that to like another degree. So it wouldn't be like 2.5, it'd be 1.5 minimum. But, you know, if it was like a real thick surface, like a leathery texture for some reason, you know, 5 mil thick, you know, you need at least 7.5 degrees of draft on it. So, and they generally they recommend, you know, that the radius, fillet radius on the inside of parts and so forth, you know, be, you know, 1 times the thickness, you know, if you can get away with it, you know, just to reduce stress. And, you know, apparently radius divided by thickness is an important ratio. You know, if its value is less than 0.5 of that, you know, greatly increases stress, whereas, you know, corner radius divided by wall thickness values of greater than 0.5, it's not too big of a deal. You know, the stress concentration really goes up, you know, when that really goes down. So as you get really sharper inside corners, you know, again, that's a good tear point for crack propagation to occur, and stress concentration as well. So basically, though, for a corner, you know, like of a box or something like that, suggested inside radius would be 0.5 times the material thickness, or the wall thickness, and the outside radius would be 1.5 times the wall thickness. So, and a bigger radius if possible. You know, there's a little more on there covering living hinges and, you know, insert molding and two-shot molding and over molding, etc. So, and gas assist molding. So, anyway, it's kind of interesting stuff. That covers the critical parts of it. Now I'll get on with the tutor. Okay, now it's for the time for the parting lines thing. Okay, we're going to select the top plane. The direction of pull, which is what that is. The arrow looks like it's, I don't know if there is an arrow on this. Come on, I gotta have a fucking arrow. Yeah, I guess that's it right there. Okay. The draft angle needs to be 0.5, which is set at. Draft analysis. Yeah, no is good. And the parting lines, you know, use these 8 edges that are the default. Not fully encompassing the part though. Okay, you can see our parting lines, you know, it's going to run right along here, and, you know, we just want to make sure there's no straddle surfaces, which is a straddle surface, which is a surface where the draft angle, you know, is going two different directions, you know, so it would cause the part to get hung up. But I don't think we should have that problem, but with this. God damn it. It's giving us a warning saying, you know, that, you know, it can't be separated into core and cavity. So anyway, I guess we're going to ignore that and just click go. Still don't know about that though. So that's our parting line right there. That's where I'd expect it to be. Okay, now we're going to go to our shut-off surfaces. Okay, you can see a shitload of tags there. I'm going to turn the call-outs off. Now we definitely want to use knit and filtered loops. Okay. I guess they're wanting to do just contact on it. So, which is the default. So, I was thinking trying to switch it to tangent and see what happens, but it's hot out there, 95. Oh, okay. Well, those generated the shut-off surfaces apparently. So, I did it on that side of the draft angle. Now we should have three surface bodies here. Okay, one's the cavity, which is the top surface, and the core is the bottom surface, and then, you know, we've got a regular surface, I mean, our part. So, a solid body, and I can hide it. So, you know, you can see kind of what it's doing here. So, pretty sweet. And hide that. So that's our core surface right there, and which goes right up flush. Our cavity goes right down into that. Okay, now we need to select parting surfaces. Select perpendicular to pull. Set distance to 10. millimeters. Knit all surfaces and show preview. Okay. Alright, and that should be up here well. So okay, now we're I have to go add a plane. Yeah, putting my filter on down there. Okay, that's the first reference. Now the distance we're going to make 20 millimeters. And we're trying to go below, so that's excellent. So, bingo. Okay, now we're going to turn draft analysis back off. I guess it is off. Now we're going to do tooling split, which is the next step in the process. Select plane pin. Normal to. Hidden lines are removed. That sounds good. Okay. Now we're going to put a rectangle. In there. Well, let me just fuck. Seriously? You fucking piece of shit. God damn this fucking dumbass program. 240 by 350. Alright, now we want to... Maybe I'm looking... Well, I mean, their origin is in the middle of this thing. I mean, I didn't draw it, so... I do have it reversed, but, well, if I have it reversed, hold on. They're dimensioning it like over here, so it's 175. Okay, with the 85, well, I guess I'll just have to guess at it. What the fuck? No. Piece of shit. Alright. That's good enough. Okay. Now it's time to exit sketch. we'll set direction 1 depth to 90 and direction 2 depth to 70. Interlock surface to be selected. And draft angle 3 degrees. That's about right. Has a pretty neat thing in there about side coring too. You might want to read. Alright, now that we've completed that, should go ahead and hide some of these surface bodies because we don't need them anymore. So, and I'll go in here and try to do exploded view. I don't know about this fucking thing. Okay, I accidentally turned on the photo view 360 thing. Where the fuck is that? Where's that parting line thing at? Yeah, I gotta turn this thing off. It looks better. I don't know why everything's white. I don't know what I'm looking at here. Oh, I don't want to do that. Go back to shaded mode. Okay, well, parting line is the last thing that was applied to it. That's how they named solid bodies. So, parting line 1, I'll hide that. What's that mean? Why do I have 2 hide buttons? I guess I can hide these too. Oh. Hide this. Hide this too. Yeah, so we got all these fucking surfaces that are hide. Okay, well, now our thing has disappeared. Unhide. Yeah, I still don't know why this is fucking white now as opposed to, I mean, how the hell did that happen? And what am I looking at? Alright, well, whatever. Yeah, I don't know what the fuck I'm looking at though. I mean, this is, I don't get it. I'm trying to make these things visible. Or not white. I don't know how the hell they get white. Not white. Okay, Ruby. Okay. Actually, yeah, I should go ahead and hold on. Press these to move, since I couldn't do a goddamn explosion diagram. Okay, so I'll choose this. Insert into new part. Top mold. And oh god damn it. Fuck! Idiots. They shouldn't put those goddamn things. Whatever. Okay. Doesn't look so awful after all. Okay. Got my selection filter on the solid body. New part. Bottom mold. Okay. I don't know how the fuck we get back to the telephone we started with. Let's see, I'm going to whirl it back through here. I don't know, it's still not far enough. I don't know what the hell happened to it. I mean, why is it white? I mean, it already says it's high gloss. I don't know what the fuck happened to it. There's no... Yeah, I mean, I don't know what the fuck's going on with it. Yeah, but I can't change its appearance in any way, shape, or form. There we go. And this should be pre-shrinkage. Okay. Nope. Just remember, it's really in the master. The master is out near the directory. Okay, I don't know what I did on my transparency settings, or what the fuck is going on. I guess the block is blue, because it turned everything blue when I hit that. Great. Oh well. Anyway, I'm not going to worry about it. Okay, let's do a assembly. Seriously? Oh, yeah, I don't have any. Shit. Well, we'll just go with this. Okay. Alright. Fucking piece of shit. Remember, this is a shrunken version, so it's not going to really fit the mold. But, what the fuck is this supposed to be? Yeah, I should fucking think so. Oh, god damn it. Okay, so now, okay, I got these brought in. I'm trying to do an explosion diagram from the exploded view. Having to select the y-axis, you know, on the gizmo there and see if that works any better. Okay, that's nice. It moved in the right direction, but it only moved one of them. Doesn't seem to get it. I mean, I don't know why these fucking idiots. You know, Rhino can do a goddamn explosion diagram and nothing flat. It's not that big of a goddamn deal. But these guys, no, they just can't fucking do it. They can't get their shit together. Solid Edge can do it, no problem. Now these guys, no, it's got to be a fucking rocket science, doesn't it? Bunch of fucking dumbass motherfuckers is what these people are. Made this program. Let's try it again. Oh, god damn it! Fucking piece of shit. I think the reason it wasn't working on this before is because it's a fixed component, but still, I thought in explosion diagrams that didn't matter. It still doesn't seem to be working. I mean, what the fuck is 10 millimeters supposed to mean? Jesus. I mean, this fucking software just sucks so bad. I mean, it sucks motherfucking hard. Go in that direction. Anyway, I'm going to torture with it. Alright, anyway, there she is. What it's going to get.